Hey guys, welcome back to another episode of robotics. So today what we're going to do is we are going to learn about how to add an ultrasonic sensor to your robot. I'm looking for my sensor here, and here it is. So if you see in the top right there, the ultrasonic sensor looks like a pair of eyes, but the thing is, these aren't actually eyes in the sense of seeing like our eyes see. They're actually little speakers and receivers. So kind of like there's a microphone and also a speaker, okay? And so there's two of them. You'll see that on the left side, you'll see a T, that stands for trigger, and on the right side, you'll see R, that stands for receiver, okay? So the trigger sends a sound out, and the receiver receives a sound in, okay? So let's go to the whiteboard and talk a little bit more about how this all works. Okay, so let's look at our ultrasonic sensor here, okay? So we have a T for trigger, and we have an R for receive. So what's going to happen is the trigger is going to send a small, or not small, but a very high frequency sound. All that means is that we can't hear it as humans, okay? But animals like maybe dogs or bats, other animals, they can hear the sound. So when I say sound, that your sensor is sending out sounds, you might think, I don't hear anything. Well, that's because we're human and we can't hear it. But it is actually sending us a sound. So trigger sends a sound out, okay? And then what's going to happen is that sound is going to keep going until it hits some kind of wall or obstacle, right? Whatever it may be. It may be a cup, could be a binder, whatever it may be. But it's going to hit something, and then what happens is once it hits it, it comes back. Sound bounces off the obstacle or wall, and it goes into the receiver, okay? So trigger goes out, hits a wall, obstacle, and then comes back into the receiver. All right, so this is exactly how echolocation works. For a bat or whales or dolphins, I believe, do the same thing, where they send the sound out and they wait till the sound hits something and then comes back. And then once they do that, they can do some math inside of their head to kind of see what the actual distance is. Okay, so what we're going to look at, let's go ahead and talk about, well, how does that math work? So if you look here, if we look at this section here to this, not section, this point, okay? So this point to this point, that's actually the distance that we want, okay? We will call this distance D for distance, okay? So if you are the Barnabas Rover and you send out a trigger sound and then back comes the sound to the receive, what you're saying then is, I want to know D, the distance, okay? Now, what we actually need to kind of be careful here, okay? We say you want D, right? But if you look kind of, if you examine it more closely, look what happens to the sound. It goes there, okay? And then it also comes back. So what I'm saying here is that the sound actually travels the distance 2 times, right? It goes there once and then comes back twice. Okay, so what does that mean? The path of the sound is actually not D, okay? We want D, but the path of the sound is actually what? This will be important later when we do our math. The path of sound is actually equal to 2 times D, right? Because the path of the sound goes out once, which is D, and it comes back, which is D. So the path of the sound is 2 times d. Okay? All right. So now that we know the path of the sound is 2 times d, let's learn a little bit more. So one thing that we get from physics and also math is that we have a formula to find distance. Okay? So the way that formula works is here, d, or distance, equals velocity. Velocity is the same time as speed. So velocity, I'm going to use v. Okay? Velocity times time, which is the amount of time that it took. Okay? So distance, or d, is equal to velocity, which is the speed of sound. Okay? The speed of the sound times the amount of time it took to go here. Okay? The amount of time that it took the sound to go here and then back to here. So let's go ahead and update our formula because what? We have the amount of time, we want to put in the amount of time that it took for the sound to go there and also back. All right, and remember, that means the path of the sound is the thing we want, which is 2 times d. So let's update that. So 2 times d equals velocity times time. Okay, so now we're getting closer. I'm going to move this over. Okay. All right, and then let's solve for d. Let's move the 2 over there. So now our new d for distance equals velocity times time. We want to move it over. So you divide by 2 on this side. That means you have to divide by 2 on this side, divided by 2. Okay? If you didn't get all the math there, again, it's okay, as long as you just kind of follow along, and I'll just show you exactly what to do. Okay? This is more to give you an exposure to how math and robotics fit together. All right, so now we know distance equals velocity times time divided by 2. Okay, so what is the velocity or the speed? Well, going back here, let's look at our chart again. Well, the speed of the thing we're looking at is the sound. So what we need to do is we need to find out, well, what is the speed of sound? That's going to be what we put into v. So, well, let's look into Google, okay? And I've actually typed it in here, so this is what I do. Well, what is the speed of sound? So we're going to look it up. Here we go. The speed of sound in dry air, I think we're going to be in dry air, is 343 meters per second. Okay, that's the speed of sound. All right, let's move back here. So I'm just gonna make some room here. Okay. Speed of sound equals 343 meters per second. Okay, so we can just put that into our formula. Remember, our formula is right here. Okay, now we do need to update it though. All right, so when we start using our Arduino, we're gonna see that we don't want meters per second for the speed of sound for the unit. We want to convert this. We want to convert this to not meters per second. We want to do centimeters per microsecond. Okay, so we need to convert the units. Now, why do we need to? The reason is because the way that the Arduino works, in order to get the time, it needs to be in microseconds, okay? Which is why we need to convert seconds to microseconds. And then for the distance, it's just easier for us to work in centimeters instead of meters, because our robot can't even sense one, whole meter or 2 meters. It can only sense, it's better like smaller distances. So centimeters is going to be better than meter. Okay. So let's go ahead and convert this one at a time. So we have, let's do that conversion. I'm going to do it here. So 343 meters per second. Right? That's what it is right now. So let's first convert it to centimeters. So to convert it to centimeters, we have to think, well, how many centimeters is in a meter? Well, there are 100 centimeters in a meter. So what we need to do is we need to times this by 100. Okay? That's going to give us centimeters. So we have, it's going to be 343 times by 100. You just add 2 zeros. Centimeters per second. Okay, cool. So that wasn't too hard. So I multiply the top by 100, and then now I have 300. We have 34,300 centimeters per second. Okay, so we're at centimeters per second. Now we need to convert to microseconds. Okay, so let's just copy the top, centimeters, but now I need microseconds. Okay, well, so how does that work? Well, 1 second, 1 second has actually 1,000,000 microseconds in there. So what do we need to do is we need to, in order to make it into microseconds, we need to divide this by 1,000,000. Okay, so let's kind of go back here. Okay, so let's erase here because we don't want that. Okay, and this needs to be deleted. We need to divide this by 1,000,000. Okay, so what that is going to end up, to divide this by 1,000,000, you could just, you know what, I'll just pull out my calculator. Okay, so we have 34300 divided by 123 123. Okay, there we go. It's let's get my 0.0343. 0.04. What was it? 0.0343. Okay, there we go. 0.034 centimeters per second. So this, let me bring that back here. Okay, so this is equal to my V. Alright, so now I've converted this guy, 343 meters per second, into centimeters per microsecond, which is this number right here. Okay, so now that we have that, let's take this right here, okay, and let's put it into here, into this V. And you guys didn't see that because here we go. So this number right here, and put it into the V. Okay, so distance equals 0.0343 times t, which is the time, divided by 2. And let's go ahead and do this, 0.343 divided by 2, and see what we get there. Okay. So 0.0343. And I could say divided by 2 equals 0.01715. Okay. 0.01715. 0.01715 times t. There we go. All right. So this is what we have to put into our code. The distance that we want from our ultrasonic equals 0.01715 times the time, the t. So how do you find the t? Well, we're going to have to go to first wire up our ultrasonic sensor, and then I will show you. All right. So now let's wire up our sensor. All right. So looking at the top right, you're going to see we have 4 pins here. All right. There's trig, or there's VCC, trig, echo, and GND. Our sensor. 2, 3, 4. VCC. We have trig. We have echo. And we have GND. Okay. VCC, that's easy. We're going to connect that to 5V. The GND, we're going to connect that to GND. Okay. And then trig and echo are the 2 pins. We're going to use pins number 4 and 5. And 5. Okay. All right. Let's go ahead and make those connections, and then we'll go to the code. All right. So here we go. I'm going to put this onto my breadboard right here, and each pin on its own row. It's going to make connecting easier. Okay. I'm going to do my GND first. Okay. First pin into the GND row, and then I'm going to go into GND on my Arduino. And then let's do my VCC connection. So VCC here. Let's connect to 5V. Okay. And then we have trig, which is, I'm going to use blue wire here. Trig, which is there, right here. Okay, this goes to pin 4. And then we have echo, which I'm going to put into there. Okay, echo. And then this goes into pin number 5 on my Uno here. Cool. Okay, so I have that set up. Now let's go to our code. All right, and before I go, let's circle our formula so that I don't forget. Okay, we're going to need this later. All right. Okay. Let's see, we don't need this quite yet. It got started a little bit just so to save some time. Okay, so we're gonna have something called ultrasonic. I actually need to update this, but I'll come back to this in a second. First, let's set up our pins, okay? So int, we're gonna have two pins that we're using. If you remember, we have trig pin, and just to make sure, trig pin is 4, echoes 5. Let's go back there. Trig pin is 4, echo pin equals 5. Okay, and then in our setup, let's set up our pin modes. Okay, so pin mode, trig pin. Now trig pin is going to be output because we're sending sound out through the trigger pin. And then echo pin is what when we receive, okay? That's going to be for the R, remember the R for receive, that's going to be input because we are listening, we are receiving something into our pin. So echo pin is going to be an input. All right, so make sure we do our pin modes, because if you don't do that, that's not going to work correctly. Okay, now we're going to make an ultrasonic function. Now, how do we want this function to work? Sends sound out and receives sound, and then it returns the distance in centimeters. So right now I have it say void. I don't want that because that means it returns nothing. I want it to return something in centimeters. So I'm going to say it's an int. It's going to return a number to me, which is going to be centimeters. Okay, so let's go ahead and do this. All right, so the first thing we need to do is send, trigger a sound. Okay, so how do we trigger a sound? This is what we do. And I'm going to copy some code right here, and I'm going to explain it to you, okay? So what's going to happen here is it takes a trigger pin, it sets it low, it just waits there for 2 microseconds. So this is new, not just delay, it's delay microseconds. So it's a really short period of time. It's going to set the pin low, wait 2 microseconds, then it's going to set the trig pin high, and then wait 20 microseconds, which is a little bit longer, but still pretty short, and then it's going to set it back low. Okay, so once you do that, that's the special sequence. So you're turning the trigger pin low, turning it high, and then turning it back low. That's a special sequence to tell the sensor right here to send the sound out. Okay, so that's all it's doing. So at this point, a sound has gone out. So now what we want to do, wait for a sound to come back. Okay, well how do you do that? We use this function, pulse in. Okay, so what that's going to do is that pulse in waits for a sound to come back. Now it actually will also tell you some extra information. It will actually tell you how long it took for the sound to come back. Okay, so how do we do that? We're going to create a variable, and it's a long type instead of int. Before we would put int here, I'm going long, okay? And we're going to call it time. Okay? Actually, you know what? Since we've always used int, well, you know, I'm going to keep it long. What's the difference between int and a long? A long is basically a longer version of int. So if you have a bigger number, then you want to use a long instead of an int. And why do I want a bigger number? Well, this number that comes back from pulse in could be kind of big, so I'm just going to keep it as long just so we don't mess things up. All right, so that's why we're using a long type here. So I have my variable time, so now I can say time equals pulse in echo pin high. Okay, so what's going to happen is that once the sound comes back, pulse in is actually going to say, okay, I got a sound, and it'll actually tell you how long it took for that sound to come back. All right, cool. So let's go back to our chart here. Oh, that's not what I wanted. All right. So the time is going to be, it's going to tell you the time it took to shoot the sound out, and also for it to come back. So that's the time that it's going to give you. Okay, so now that we have that, oh, and then just so you guys know, the time that it gives you is actually in microseconds. All right, so that's why we need to remember here. Remember this, we convert it to centimeters per microseconds. That's why, because pulse in gives you back microseconds. So now that we know all that, we can use our formula here. Distance equals 0.0175 times the time. So let's 0.01715. Let's see if we can remember that. Probably not. Okay, so let's get our distance. All right, so we're gonna have this float distance. All right, now it's like, okay, all these different variable types. Before, these were all ints. What's up with this? Well, float means that you might have a decimal. Okay, so we might have a decimal when we do the math, and so that's why we want to use float. All right, so now distance equals, I already forgot, 0.01715. 0.01715. Okay, and this is a decimal right here, right? This is a decimal. That's why we need to use float. All right, so times the time. There we go. And that's it, because we did all the math before. This part's pretty easy. And so this is calculate the distance in centimeters, right? Because if we go back here, remember we did this, remember we converted from meters per second to centimeters per microsecond. So what comes back is actually centimeters. All right, I think we are almost done. Then we say return the distance. Okay, there we go. I think that should work. Let's see. All right, so we're gonna go ahead and test our ultrasonic function. Now to do that, let's go ahead and print back from onto the computer screen what the robot calculates. So the way we do that, first we got to go in our setup function here and say serial.begin 9600. All right, what that does is that it sets up what's called the serial monitor on the Arduino so that it can start sending information to your computer screen. All right, so serial.begin 9600, you put that inside the setup, and then in our stuff here, all right, I'm just gonna leave some of this stuff here. I'm gonna say serial.println something. What do I want to print? I want to print the return value of ultrasonic. Okay, so when it sees this, it's going to calculate ultrasonic, the function we just wrote, and then send that to the serial monitor so that we can see what's on the screen. I'm going to put a delay 100 here. The reason I want to put the delay is so that it doesn't keep doing the ultrasonic and trying to print over and over again super fast. If there's no delay, it does it super fast and it gets confused. So I want it to chill out for 100 milliseconds before it does it again. Okay? Because you remember, all this code goes in a loop, right? Because it's inside this loop function. All right, let us try this to see what happens. Okay, I'm gonna plug in. I'm gonna upload. Trig pin. Oh, it says some errors because I just copy and pasted it and didn't fix this. Okay, so line 47. Okay, here, trig pin. There is no trig pin because if I go up, my trig pin looks like this. It's trig underscore pin. All right, so let's fix these. Trig underscore pin. Trig underscore pin. Trig underscore pin. All right, and then these, now that I know that, this should not be echo pin, this should be echo underscore pin. Okay, because then that matches this. Okay, cool. Let's try again. Okay, looks good so far. Okay, I'm going to move the camera down to the bottom right so you can see what's going on here. So now, actually, we're okay. You can see it here. If you look over here, once you've uploaded it, there's two tabs here, editor and monitor. If you click on monitor, this thing comes up again. And then you can connect and it should start showing information. Okay. And it's working. So right now, it's looking at something. Let's see, maybe I'll grab my phone here. Okay, if I put my phone here, see, look, it's saying 5. 5, 4, 5, 4, 5, 4. I go closer. 2, 3, okay, and then I go further. The numbers get bigger and bigger. All right, so right now, if you look, I'm about 11 centimeters away. I go further away. It goes 15. All right, so it looks like my code is working. All right, so, and let's see how far it can go here. You can go further, pretty far. I'm just using my hand right here and moving my hand back. Very cool. So it looks like it is working. So that's good news. Let's go back to my editor here. And so let's write some challenges. Number 1, create ultrasonic function that returns distance in centimeters. Okay, so basically just follow exactly what I did. All right, and then make sure that function works. So doing the test that I just did where you put your hand in front of it, the numbers on the serial monitor should change. All right, so number 1 and 2, you just follow exactly what I did. And then number 3, which I'll do right now, create moveToWall function. moveToWall function. All right, so now we're going to create a function that moves to the wall and then stops. So here we go. Let's find move forward. Move forward is right here. It's going to be pretty similar to it, so I'm going to create it around there. I'm going to say void moveToWall. Okay, and let's go use our speeds too. We get speed A, int speed B. We don't need inches, okay? We don't need inches because we don't actually know how many inches we want it to move. We're just saying move to the wall and then stop. So we don't need inches. All right. So the first thing we're going to do is move forward. That's easy. We've done that a lot. So I'm going to go to my motor A, motor B stuff and just copy this. Oops. I'm going to copy this and paste it in. All right. So this is nothing new. We're just saying move it forward. Now, stop when you hit a wall. So what do I do here? Well, we have our ultrasonic function, so we could do something like this. We can say int distance equals ultrasonic. All right, remember ultrasonic returns back the distance in centimeters. And we can say while distance is greater than 10, or I'll say 5, do nothing. Okay. Well, actually not do nothing. Do nothing except check distance. So what that means is that while the distance, so while there's nothing there, or while objects are more than 5 centimeters away, just keep going. Don't do anything. Except keep looking. So I have to say, you can't just all of a sudden close your eyes, because then this whole thing's going to fall apart. So you have to say distance equals ultrasonic. Now you may think like, well, I did it here and I did it here. It looks like the same code. Why do you keep doing it over and over again? Well, ultrasonic, what comes back to you changes, right? Because if you get closer, ultrasonic is going to give you a smaller number. If you get further away, ultrasonic gives you a bigger number. So you have to keep checking. So you have to keep saying distance equals ultrasonic, distance equals ultrasonic. Just keep checking. Okay? So you keep going, and then as long as the distance is bigger than 5 centimeters, just keep going. But once it's not bigger than 5 centimeters, stop. Because you don't want to hit the wall, right? And I think I have a function to just stop. I think I do. Here, stop. Yep. Okay, that's it. That is it. All right, so let's do a move to all. All right, so I'm not going to do the move forward here. So whenever I press the button, move to wall. All right, so now what should happen is that when I press the button, it should keep going until it gets to the wall. But hopefully it doesn't hit the wall. Let's see, I messed up here. Oh, I forgot that move to wall has speeds too. Okay, let's go, I don't know, 120 and 120 for the 2 motors. Speed A. Okay, let's see, I think I messed this up. Let's go to line 121. Oh, I see. This here should say speed A to match that. All right, one more time. Upload. Okay, and I can turn on my monitor too to see what my robot sees, because that code is still there. Okay. All right, I'm gonna move my robot back, and let me put my phone here. Okay, so it sees 19, right? So I'm gonna press the button. Sees 15, 16. Okay, I'm gonna press my button here, and then hopefully it goes. And then it stops. And look, it's like 6, 5. Okay, let me try again. It's totally working. Totally working. Pretty cool. All right, so let's give you some challenges here. Sorry, my computer is giving me some messages. Okay. Okay? Create moveToWall function, so do exactly what I do. Then I want you, some extra challenges starting at number 4. When you stop, back up and turn around. So rather than just stop at the wall, I want you to go back up, like beep, beep, and then turn around. So that's some extra moves to do. And then another one is, can you do this? Once you see a wall, stop and keep going. Wait, stop, back up, and turn around, and keep going, looking for walls. So what I mean by that is that once you press the button, I want it to go, see a wall, stop, back up, turn around, and then go again until it hits a wall, stop, go back, turn around. All right, so the idea is that if you put your robot here in a box, it will just keep stopping, turn around, and it should keep moving but never hit the box. Does that make sense? All right. So the idea is that once you get it to work, you could take your robot and put it in like any room or a small room like a box, and just keep moving around but never actually hit anything. All right, so that's kind of the extra bonus challenge for this week, because that one might be a little bit challenging. All right, there we go. A little bit longer video. So if you need some more time, totally no problem. But I think this will be exciting to get your robot to start to see, and we got to learn all the math behind everything. All right, that's it for now.